Hey guys, this is your Cycle 2 data distribution walkthrough. And I kind of want to take what we've learned from Cycle 1 and Cycle 2 guided notes and put them together and just kind of have one data set and do some multiple different things with it. So this is a sample of data that was taken from Cycle 1, Cycle 2 test scores of students at Westland High School in 2017 in my third period class. And so these are just a sample of those test scores. So I want you, with those test scores, I want you to create a box and whisker plot. So we're going to do this part together. So the first thing we want to do is we want to put these numbers in order from least to greatest. And so I already did this on another sheet of paper. So I have the answers really quickly for you. And so I'm going to write them right underneath. So you write what I write. So we have 23, 31, 32, 33, 45, 54, 54, So before I move on, I make sure that I started with 15 numbers in my original data set, and then after I put them in order, I counted and I made sure that I had all 15 numbers. So it's really important that when you write data from least to greatest, sometimes it can just be kind of tricky, like you forget a number or you add a number twice. So make sure that you're really being careful and double checking your answer, because if you mess up writing them in order, everything following could be messed up because you just made a simple mistake in the beginning. So really just go back, take the extra 30 seconds or so to double check and make sure you have the data correctly done. I think I do. Hopefully I don't have a mistake on here. So we're going to use this data to create a box and whisker plot. So the first thing I want to do is break my data in half. I always think of that cookie analogy. So I'm going to break the data in half. In other words, in math terms, I want to find the median. So I know there are 15 numbers in this data set, so I'm going to count 7 numbers from each side, and then that number in the middle will be my 15th number, and it'll be my median. So let's count. So my median is 55. So I'm going to put over here my median is 55. And then that's breaking it in half. So now this first half, I want to find the median of this first half. So I'm going to cross one off at a time. And I find that my quartile 1 is 33. And I want to do the same thing over on this side to find my quartile 3. So my quartile 3 is 79. So let's create a box and whisker plot. So I'm just going to do this on a number line counting by, let's do 10s. We'll see what that looks like. Okay, so I just counted from 10 to 100, so I don't need all that extra space. So each one of these is counting by 10. So I know that my smallest number is right here at 23. So it's going to be right about there. My quartile 1 is at 33. My median is at 55. My quartile 3 is at 79. And my highest number is all the way up there at 99. So connect the tops and the bottoms and connect my whiskers. So that is a box and whisker plot of this data. Let's just recap really quickly. When we do a box and whisker plot, the analogy that we want to have come to mind is that there's 4 of us, there's one cookie, we break it in half, we take the first half, break that in half, we take the second half, break that in half, and that takes all of our data, breaks it into 4 equal parts. They're all representing 25%. And we have this displayed on this box and whisker plot. And so now we have some questions we want to answer. What is the IQR? So remember, the IQR is Q3 minus Q1. So in this situation, our IQR is 79 minus 33. So 79 minus 33 is 46. So our IQR is 46. Again, that is just the width of our box. So that is our IQR. Interquartile range, the range of our box. Are there any outliers? This data set looks a little tricky. I think some people might want to argue that some of the higher numbers or the lower numbers are outliers. I don't think so. I think if you put this on a dot plot, there's a wide range of numbers, but there's not a number or a number set that's really far out there, like obviously an outlier. So for us, I think we're going to say that no, there are no outliers in this data set. There's not really a number or a set of numbers that seems like really oddballs out. Now, their range is really big, so we start way down at 23 and we end at 99, but there's still some 97, 96s, 79 is pretty close to 80, so it's not like those higher numbers are really far off, and then there's still some numbers down in the 20s and 30s, so it's not real obvious, so we're just going to say no. For right now, there aren't any outliers. So is this data symmetric, right skewed, or left skewed? So if you look at your box and whisker plot, we did this by hand, so you want to be really careful and try to make sure it's really neat so that it doesn't look skewed because you messed up by hand, but rather the data is what's making it skewed. And again, this is pretty tricky because there's a couple numbers in the 30s, the 40s, the 50s, the 60s. Like, there's kind of numbers all over the place. And to me, it looks pretty symmetric. And so I'm going to write that. It looks pretty symmetric. It might be, so maybe slightly, so I know that it's going, I feel like it's going up and then down to the right. So when we say down to the right, then we're saying that it's slightly right skewed. So if we go up and down to the right, then it's slightly right skewed. In other words, if the right side is kind of thin and the bulk of our data is on the left side, then we say that it's right skewed. Okay, so here's kind of a cool question I think that you might see on the air test. If the highest value was taken out of the data, what would it do to the mean and the median? So first of all, let's just write down our highest value. So in other words, let's pretend these are our test scores, and let's just think common sense for a second. If I have all of my test scores, and I have this average, my average for my class, and I did really well on this test, and I got a 99, and the teacher was like, well, I'm going to take that test out of the data. Would you be happy or would you be sad? If you'd be sad, that probably means that that's going to bring your average down. If you would be happy, that's going to mean that's going to bring your average up. And I think if our teacher or I said, I'm going to take your highest test score away, I think all of us would be pretty upset because we realize it's going to bring our average, our mean, down. So let's remember that our mean is our average. So I went ahead and calculated this, and I think this is the only way that you're going to be able to answer this question. So I went ahead and said our current mean, if I added all of our numbers up and I divided by how many there were, I got 59.93. If I take 99 out, then my new mean became 57.14. So the mean went down. The mean decreased. Which that makes sense. If I take out your highest test score, you're not going to be very happy because your average in my class is going to go down. The median, I want you to kind of visualize this whole list of data, and it's from least to greatest. If I take off that biggest number, I kind of have to shift. My middle is going to shift to the left a little bit. It's going to shift down as well. So I found my current median. And my current median is 55, and we already saw that way up here when we did our box and whisker plot. So if I took off this data right here, this is going to shift left a little bit because the middle is going to be shifted to the left a little bit. And so my new median became 54.5. It didn't shift that much, but it did go down. So my mean decreased and my median also decreased. Now I want you to think about if I added, let's say, a test score of 100, what do you think the mean would do, and what do you think the median would do? If you add a test score that's really high, what's your class average going to be? Your class average is going to go up. So if I'm adding something on the high end, my average is going to go up. That should make sense because that's what we do with our grades. If I add something to the high end of my data list, my median is going to shift. The middle of my data is going to shift a little bit to the right because I added something on that side, and so you kind of want to think of it as a scale. If I'm adding something to the right, then the middle's got to shift to keep those two balanced, those two sides balanced. And so if I am adding something on the high end, it's going to increase my mean and median. If I'm taking away something on the high end, it's going to decrease my mean and median. And then I want you to kind of think too, what if I add something on the low end? What if you have a test score and you get like a 0? Like you're cheating, your teacher takes your test, and you get a 0. It's going to decrease your average. It's going to decrease your mean. It's going to decrease your median. So I want you to try this bottom half on your own. And when you're completely done with putting it in order, making a dot plot, answering these questions, filling in these bubbles, then I want you to come find me so we can look at your answer key and make sure you fully understand how to work with this data set to find all these different things. Okay, hopefully that all made sense. Let me know if you have questions.